All right, so this video is about parallel and perpendicular lines, and this is again a review of some topics that you were supposed to cover in Algebra 2 course. So if you're confident that you can identify parallel and perpendicular lines from the equations, then go ahead and skip this video. But if not, then stay with me. Okay, so parallel lines. This is the illustration of parallel lines. Parallel lines never cross, and that happens because they have the same slope. So parallel lines have the same slope. But different y-intercepts. So if you were to look at, so let's say we have one function m1x plus b1, and then we have another function, we'll call it g, with a slope m2 and the y-intercept b2. Okay, so if the lines are parallel, then m1 equals m2 will indicate parallel lines. Okay, so that's the criteria. Now, what about perpendicular lines? Let's see. Here's a picture, perpendicular lines and lines that cross at the 90-degree angle. And again, how do we know? So if two lines, again, f of x is m1, the first slope, times x plus the y-intercept, and g of x has a different slope m2 and a different y-intercept, but if they are perpendicular, then their slopes are negative reciprocals of each other, which means if you multiply them, m1 times m2, you're going to get a -1. If you solve this equation for either m1 or m2, you're going to get m1 equals -1 divided by m2. This is where the negative reciprocal comes in. Okay, so those are the properties, and that's how you can identify them by comparing their slopes. So the slopes of perpendicular lines are going to be negative reciprocals of each other. If you multiply them, they will multiply to a -1. And for the parallel lines, they're going to be the same, while their y-intercepts are different. So let's take a look at a couple of examples. So here we have example, find the equation of line perpendicular to f of x equals 3x plus 3 that passes through the point. Actually, before I do this example, I want to do another one, 15. Okay, so let's skip to that example first, and then we're going to come back to writing lines. So here we have two lines, and we need to determine whether they're parallel, perpendicular, or neither. So first, before we get to answering this question, we actually have to rework our equation. So they looked something like this in this form. This is called a slope-intercept form. It gives us the slope, it gives us the y-intercept, so we need that form. And what that means that we're going to solve each equation for y. Solve each equation for y. Okay, so we're going to start with 4x minus 7y equals 10. Solving for y, bringing 4x to the other side, negative 7y equals 10 minus 4x. And then dividing by 7, negative 7. And remember, we need to divide out every single term. So we get y equals negative 10 over 7, and then negative 4 by negative 7 is plus 4 over 7x. Or if we rewrite it in the form that we're used to seeing our equations, we put this term first. So 4 over 7 x equals, not equals, negative, minus 10 over 7. So that's our equation of the first line in slope-intercept form. Let's do the same thing for the second one. So we have 7x plus 4y equals 1. So bringing 7x to the other side, we have 4y equals negative 7x plus 1. And then dividing everything by 4, we have y equals negative 7 over 4 plus 1x plus 1 over 4. Okay, so now this equation is also in the slope-intercept form. I'm going to call this equation 1, so y1. This equation 2, so y2. Okay, so now we have to compare their slopes. If they were parallel, then their slopes would be equal. What is the slope of this line? M1. That's 4 over 7. What's the slope of the second one? M2. That's a negative 7 over 4. Okay, so obviously they're not the same, so the lines are not parallel. Are they perpendicular? Well, are they negative reciprocals of each other? So reciprocal means flipped, right? So they are reciprocals of each other. Are they negative reciprocals? Negative means their signs are different. One is positive and one is negative. And yes, we have that. We observe that. Let's just verify that this is the case. So M1 times M2, we expect that product to be, M1 is actually 4 over 7, but I'm going to start with M2. And then multiply by 4 over 7. Well, 4 and 4 cancels out. We're left with 1 and 1. And 7 and 7, same thing happens. So what do we have? We have negative 1 over 1 times 1 over 1, which is a negative 1. So yes, M1 times M2 equals negative 1. Therefore, the given lines are perpendicular. So that's how you check. Now let's talk about what do you do if you need to write an equation of a line that's parallel or perpendicular. So that's our example 13. Find the equation of the line perpendicular to this one that passes through the point. So guys, remember this. In order to write equation of for any line, all you need is the slope and a point. Slope and the point will do that. If you have a slope and a point, then you could either use your slope-intercept form. That is, if you have a specific point, a y-intercept. But if you don't, then you could use the point slope form of the equation. Again, this equation takes any line. It doesn't have to be the y-intercept. So in this case, the point that we have is actually an x-intercept. It's not a y-intercept. So we would have to go with this equation, okay? Now, where do we get slope for the line that we need? Now, they gave us a line that would be perpendicular, right? So this is my M1 of the perpendicular line. So I need to find the slope of my line since it is, I'm going to have M1 times M2 equals -1. So this is what I need. This is what I have, right? 3. That's the slope of the perpendicular line. So this gives me my M1 times 3 equals -1. So M1 is -1 divided by 3. Okay, so that's my slope. And I also have a point. I'm going to use this equation now. Y minus y1, that's a 0, equals m, which is -1/3 times x minus x1. x1 is 3, x coordinate at that point. Okay, I'm done, guys. Done. We just need to distribute -1/3, 0. We don't have to worry about it at all. It disappears. So we have -1/3 x minus, okay, -1/3 times -3 is actually a +1. So it's going to be +1. And that's it. That's my equation. So guys, remember, a point and a slope. And if they give you the line perpendicular or parallel, they're giving you a slope. All right. So I want you to try this problem yourself. It says, give the function h of x, or given if the function h of x equals 2x minus 4, write an equation for the line passing through 0, 0. Okay, and actually they wanted to write two different lines. One is parallel to h and another one perpendicular to h. So again, you have a point, you need the slope, and the slopes will be different for parallel and perpendicular line. Go ahead and try it. And the last problem that I want to go over is example number 14. It says a line passes through the points -2, 6, and 4, 5. Find the equation of a perpendicular line that passes through the point 4 and 5. Okay, I'm not gonna actually solve this all the way. I'm just gonna give you the outline, what you do in this case. So this point is on our line. This is our line that we want. Okay, now these 2 points are on a different line. And these 2 points do not belong to this to our point. I just want to make that clear. That's a different line, which is actually perpendicular to ours. So this is these points on the perpendicular lines. Okay. So what you want to do first, you're going to find the equation of this line, get its slope, write it in the slope-intercept form, get the slope. Actually, you don't even have to find the entire equation, as long as you find the slope of this line. Okay, guys, so here's the visual of what's going on. So we have a line through these 2 points, negative 2, 6. Let's plot those points. And another 4, 5. That's another point right here. So that's the given line. Right? And then they say, they give you another point and say, we're interested in the line that will be perpendicular to this one and goes through the point 4 and 5. And 4, 5 is right here. Now, in this instance, it's on the line. So they're looking for the line that goes perpendicular. All right. So, but it doesn't have to be. Sometimes they give you a point somewhere here and you have to find the line perpendicular through that point. So it's not always on the line. But the point is, this is the line that we're looking for. Okay. That's where this point is. But the blue one is the line that's given. So this is kind of a reference line, right? So in order to find the equation of the perpendicular line, we first have to find the reference line, okay? And then go on and look for another line. So here is it's a two-step process. So first you find the equation of the reference line, and then you use it to find the equation of the line that they're asking you to find.